Welcome to the High Dimensional Podcast. On this episode, what you'll hear is a conversation Phil and I had on the latest trends in AI and how they're impacting healthcare data. We discuss a number of topics, including a tool that Phil built at Atropos to normalize medication data using GPT-4. You'll also hear how we think AI could completely transform the healthcare data generation process and what that might mean for the broader industry. A really fun conversation that you'll hear now. Welcome to the High Dimensional Podcast, Phil. First episode.
Thank you.
Great to be with you.
The Phantom Menace, I think, is that what we're calling episode 1? Or...
That's definitely what we should call episode 1. Yeah. And then if there is an episode 2, we could, see if we stick with the Star Wars theme.
Well, much like episode 1, the Phantom Menace, there's a lot of fine-grained trade disputes that occur in the healthcare data world that actually kind of power everything. The story you see is not the real story.
Well, let's get into it. So
yeah, let's get into it.
Episode 1, I think we thought we were going to talk about kind of like AI stuff, right? AI is on top, everybody's top of mind. You and I talk about it all the time, just in conversation. One thing that I was really curious to dig into is just like, let's go through the use cases that we're seeing a little bit, and what do we think's like working now? What do we think will work in the future? Like what's hype, what's real?
Sure.
My favorite use case, if I could just pick one to start, that I've seen right now on like the data, like the healthcare data side of things, is actually the little POC that you created for Atropos. So maybe let's just talk about that first. I mean, you can give a better summary of it than I can.
Yeah, absolutely. So just to back up for a second, the challenge that we were trying to fix, and this is all online in our generative terminology mapping white paper, the challenge that we were facing, which is pretty common across healthcare data sets, is that oftentimes you have just sort of text representations of medications, so medication names principally, and you don't actually have that connected to any kind of terminology system, which is odd because, as you and I both know, Aaron, there is always a terminology system within the EHR. At the very least, you're almost certainly going to be tracking NDCs for billing purposes. You probably at this point in 2025 are also tracking a bunch of, some kind of clinical terminology system so that you can run your allergy checks, your dose checks, all sorts of clinical decision support off of your medications. But in any case, sometimes when the data it comes through, those terminology systems are not included for one reason or another. So we were working with data where about 40% of the medication data just had these string names. And that obviously makes a nightmare for analytics. You're trying to find all the patients that had medication A, and so you are doing some kind of fuzzy free text search across 200,000 medication names, and you're picking up things that are wrong. You might even not want to just look at medication names, but you want to pick particular forms of the medication. You want to pick only the pills, you want to pick only the injections, etc. So now you have to account for all of the variations of like pill, cap, injection for solution, all of these things that are that can have variation. So you really want a medication terminology, and we set up a system. I know I'm getting kind of off track here potentially, but set up a system.
No, that's good.
We set up a system where there is a UMLS API that allows you to take a string name and bounce it against this UMLS API and get a RxNorm code back out, which is a nice structured terminology system for medications. The challenge is that is not always correct. So when we did our analysis, it was like 92% correct. At the ingredient level, that 92% of the time we had a human expert judge whether or not that map from the MLS API was actually correct, and it was correct about 92% of the time, which is great.
And for people that may not know, what is UMLS?
Oh, I'm trying to think of what the acronym means. Let's see.
I know. I was just trying to think of it too, and I was like,
It's
I
like
don't know. And I was like,
unified.
Phil will know.
Oh
But
man. Let's see. Unified
essentially, it's
medical language system. There we go.
in it, but ostensibly, it's like a huge collection of like healthcare terminologies and ontologies that you can access over the open internet. And I think it's funded. It's federally funded.
Yes.
I
Yeah.
is it through NIH or
I believe it is through the NLM, which is part of NIH.
that's right. Okay.
Yeah.
Okay, but you were getting what you were getting to is basically UMLS has an API where you can basically submit through that API a description like, hey, this says acetaminophen,
Yep.
and then you can get back an RxNorm code from that API.
Correct.
And when you experimented that as a solution, the accuracy of that was 92%.
Yeah, the ingredient level accuracy. So, 92% of the time, if you put in acetaminophen, you would get back something that was ingredient correct. So something with acetaminophen, which, 92%, that's pretty solid. A lot of people would be pretty happy with that. However, for analytics purposes, it's not exactly where you want to be, right? Not for something that's really going to be production grade. So what we did was take that, we did that first step. We took our string, we bounced it against the UMLS API. We got a candidate RxNorm code match. And then we bounced that against a LLM and had the LLM either approve or reject the match. And this was not, I think at the time it was the original GPT-4, not 4.0. And so not something that was medically trained in the medical domain specifically. We didn't fine tune anything. We didn't, we pretty much just presented this, like the name, the string, and then what the candidate matches name, the name of that RxNorm code, and had it just say yes or no. And so after taking results of doing that for several thousand of these, we had about 200,000 of these to distinct strings to match. We did about 2,000 of them, and as part of this sort of exercise POC, and our human expert judged that essentially we achieved 99.7% accuracy after you kicked out the incorrect ones. And I have to say, for the 0.3, arguable. Like, I think reasonable people could disagree. I think we put in some really stringent guidelines to say, even if, and I'm not a clinical expert at all. I think the last time I did chemistry was in high school, so I'm really just sort of reproducing what was told to me.
That's good.
Was that the salt was slightly different. So, we considered that to be incorrect. Our clinical expert considered that to be incorrect. When we asked some other folks, I think basically what we got to was that reasonable people could disagree as to whether or not those were actually incorrect. And yeah, so I think that, just for context, we sort of estimated how much it would cost to have a person go through and do 200,000 of these matches, and it was several $100,000. And the total cost of our POC was, I don't recall the exact number. We sort of had to do a bunch of math about it. Okay, exactly this many tokens and this much time on the Databricks runtime, and etc. But I think it was about 2 orders of magnitude, roughly, smaller than having somebody do it.
Yeah, so it's interesting because the way this is normally done is like, or the use case for all this is you have a bunch of clinical data, electronic health record data, and you're trying to use it for analysis of some kind, secondary, analytics, or like generating real world evidence from a secondary use standpoint. And without these codes, you can't do data analysis. It would just be a bunch of pattern matching. You couldn't do good data analysis. And so the typical workflow for this is hire a very expensive person, usually a clinical informaticist, typically medically trained, to go in and review these things one at a time and make a decision about what the code is. And so that is basically the labor that this kind of proof of concept is demonstrating that you can replace. The other interesting thing to me about this is I remember, I think this was like November 23.
Yeah, it was a while ago.
It was a while ago.
Yep.
Because I remember I was in the airport with my family about to go on like vacation for Thanksgiving, and you texted me. You texted me some of the result, like, "Hey, I've been working on this. Here are some of the results." And you didn't actually spend that much time building the POC. I was like, "How long did it take you to get to this point?" You're like, "I don't know, a couple of days." And I was just like, "Whoa, like time out." So that's like definitely, I think, my favorite.
This was before any of the reasoning models, and one of the things that we included was asking the model to explain its reasoning, before a reasoning model. So this is sort of like ex post facto reasoning, in a sense. So, and I think that that's the other, having worked on a lot of these mapping things, that's another big challenge, is that you can have different people go in and make a map, but if you then want to have them inscribe exactly why they made that map, or like, if you have your sort of curation policy and has a bunch of rules and stuff, you're already kind of going through a slow process by having people have to review the source data, look at the curation policy, and make their decision. If you additionally then make them write down which exact part of the curation policy they followed and like why that's applicable, you slow it down even more. And so having something, and I think, there's a huge, I think there's a reasonable discussion to be had about whether, like, many people would say, oh, that's not reasoning. It's just, next token predicting something that flows after the decision that it actually made, right? Like it's not telling you why it actually made that decision. It's just sort of generating something that flows from that decision after it already, quote unquote, made the decision. But I think that even just having something there is valuable in order to refer back to and to have the ability to loop back and assess later on. And I think actually when refining the prompt, which again this is all published in our white paper, so like we actually put the prompt in there. When I was refining that prompt, having the model explaining itself every time it made a decision really helped me make tweaks to the prompt. And I think that was like a key part of it. I also just think that, the other aspect of this, there are a lot of traditional NLP approaches to solving this problem, right? I mean, the solutions that are out there are not only have a person look at 200,000 rows in a spreadsheet and make a decision. There's a bunch of sort of traditional NLP approaches. We did actually test against one such approach, and this one outperformed it by quite a bit. And I think that there are probably a number of reasons for that.
Your LLM approach outperformed the traditional NLP approach by quite a bit. Yeah.
And I think, probably the biggest reason was that actually from whenever that model had been trained to map to RxNorm, there have been, it was a few years ago. And so there were new medications that had been released in the meantime. There were changes to the RxNorm coding system. There were codes that had been deprecated and other ones that had been added and stuff. And so that model, it didn't perform terribly, but it just didn't perform as well. And in, I think, a significant part of the degradation of its performance was that it was just outputting a bunch of stuff that wasn't valid anymore in 2023.
Have you, since working on medications, experimented with other types of data, lab test results, low-ink codes?
Yeah, so I think that's the very reasonable next question is like, okay, well, if we could do it for that, can we just generalizably solve this problem? And
Yeah.
I think the thing there, so the answer is no, I don't think you can like it's not a solved problem for labs. I mean, I think arguably it's not a solved problem for medications either, because there were some things about our source data that, we weren't literally taking free text. We were taking structured fields from a bunch of different EHRs and putting that through the UMLS API first.
Hmm.
And so it wasn't literally just, like Scratchpad, like, I don't know, an email or like a web forum or like something that was truly free text. Um, and then also we had this pretty high quality UMLS API that provided the first step. So I think the problem with labs is, at least I haven't been able to find something to do the first step very well.
The kind of the API analogy or whatever that would be for Loink. They do have, I think Loink has like pretty good like kind of rules that you could maybe feed into the LLM as a prompt, like kind of guidelines.
Yeah, and I mean, this again was a while ago. So like now we have Gemini, what is it, like 2 million
Mm,
token context windows and stuff. So like you
right.
definitely could get something going where you basically, yeah, and to be clear, I've been continuing to work on this in other respects, and hopefully can release something about it soon. But I think it's still not a solved problem, and I think a lot of it also boils down to the limitations of the data and the limitations of the coding system that you're trying to map into.
Well, and maybe just kind of wrap on this topic, which I mean, I could talk about all day. I love this use case, but um, to go back to the very first thing, or one of the things you were saying at the beginning, and we've talked about this before. It's like, how is the data generation process for this like so broken? Because we know the terminology does exist at some point very far upstream,
Yeah.
and then it just gets lost in the middle, and then it does get inserted like for the purposes of billing later downstream. So it's like we have just got to find the expert. There's some person at some hospital or health system somewhere who knows the answer to this. We've just got to find that person and do an episode on that for them
Yeah.
to like tell us what the heck is actually going on here.
Yeah, I mean, I think my guess would be for medications, a lot of it probably boils down to the clinical terminologies that are used. Many of them are highly proprietary, and so they can't just be like shared. Like you can't just put potentially. That could be why people are not including them when they're extracting data. I think why there's not just an NDC though, yeah, I don't have a good answer for that. Like I think at this point most EHRs are going to store NDC information because unless you have a completely
For the
separate
bill.
yeah, like unless you have a totally
Yeah.
separate billing system and there's some sort of which had, in 2025, I feel like that's got to be pretty rare at this point. I would love to know the answer to that actually. Like who is just having totally separate clinical and billing systems at this point.
Yeah, maybe just to like touch on like what are some of the other use cases that you're most excited about with AI and health data or healthcare generally?
Yeah, I mean, I think there's definitely a lot. But I think we're far enough into this now, a few years down the road, where I think that many people have been experimenting, and I mean, I'd be interested in what your opinion about this is. My sort of thought is like it's not we're past the point now where people haven't thought to try things, right? People have definitely been working on these problems for a long time. People probably have been now like 1 to 2 years in. People have thought to apply LLMs to these problems, and so if we're not seeing huge product releases and adoption, I have to imagine that part of that has to do with the fact that there are sort of hangups and lack of reliability and stuff like that are entering into the process somewhere. So I don't know.
Yeah.
What do you think? Like,
Well, I mean, I think there's definitely the use cases where you see the most investment, right, are from like venture capital are definitely like one, the kind of like ambient listening, like a
Yeah.
bridge style company where, a bridge is like clearly like emerging as like the leader. That's gotten a lot of attention, a lot of investment, and I believe like actually on the heels of like commercial traction where they're like you know making sales and like so I think that's like being implemented in production, and that's obviously getting a lot of traction. Just to put a pin in it, I think the interesting thing is that potentially comes out of that is like that potentially changes the entire data generation process. You and I have talked about this before, but potentially like the way data is generated in the EHR today, right, is the doctor sits down while they're or the medical student or the scribe or whoever the person is that's at the computer when you're being seen. They're banging away at the keyboard and the mouse, and that's how data entry happens in healthcare today. And behind the electronic medical record system, there's a relational database that is capturing a lot of that information, and then that's kind of how the whole process
Yeah.
starts. And with these medical scribes, I'm not, I don't, I don't have any hands-on experience with these tools, so everything I'm going to say is like me just like imagining what's happening. So, uh, maybe I'm understanding correctly. I mean, it seems like this is probably what's happening, but I we should probably have somebody from a bridge or one of these companies on the pod to like actually learn what the heck is going on. But they're essentially listening to conversation, and they're recording that audio as I assume like wave files or some sort of file format. They're transcribing it into text, um, and then from there it's actually like, is that text then is the LLM then going from the text and inputting it into the EHR? Like, is the LLM like replacing the banging away at the keyboard and the mouse? Like potentially that's potential. I would guess like that's what's starting to happen, or that they're on the road to that happening. Like I would guess that's kind of the integration, or there's some sort of API or something where they're trying to um, do it that way. But like long term, we might not even need this backend database. We may not even need like this way of doing things could totally with the LLM at kind of the center of it. Do we even need to store data in the same way that we did before? Is the entire data generation process disrupted? Is all data actually just stored as text?
Mm.
And then the LLM, which obviously like text is like gasoline to the LLM. It's like, gasoline to the car, text is to the LLM kind of. Is the whole corpus of data just text? And then the LLMs are like the agents that are doing the things. And that when they need information, they're just reaching into the text to get it and load it into their.
I feel like this is where there's got to be a name for somebody has to put their name on this already, but I just feel like I've seen in data engineering discourse over years now the sort of the iron law of never bet against SQL. The like everybody is like, oh yes, I'm gonna disrupt SQL. This is stupid. I'm gonna have my declarative language. I'm gonna have I'm gonna get out of the relational database hell world that we all live in. And obviously someday that may be true, or maybe like in 50,000 years we'll be on like a star destroyer like typing in like select star from exhaust port where like
Yeah, I guess at that point it's like, are you talking to the LLM and the LLM is writing the SQL?
yeah.
Is the LLM still writing SQL, or is the LLM figured out some whole other thing
Well,
that
I
SQL
mean,
isn't?
when you have the LLMs do math currently, it's writing Python. So I think I wouldn't be surprised, honestly, if SQL ends up being the final database management tool for all time.
Yeah, I mean that's kind of my like kind of steelman argument for like where relational data is not going away, even in
Yeah.
some future. It's kind of like if you are, data analysis is essentially computing statistics. Computing statistics is like, doing a statistical operation over a set of numbers,
Yeah.
right? So how, like, think about calculating an average or a sum, or something simple like that. For the LLM to do that and do it like precisely and not get a different answer, like it's going to probably store the data in vectors or something, and then as soon as you're on that thread, you're more or less, that's relational data. So
Yeah, I mean, I just think this is more of a vibes based approach than a reasoned argument, and I do think that I would love to talk with someone from Abridge, or maybe at some point we could actually talk to clinicians, but we might have to like obfuscate their appearance and give them the like voice filter to anonymize them, to like have what's the
right,
real, I want the real deal,
right,
because I think that a lot of people, and me included, see this potential in LLMs to kind of undo the tremendous harms of the EHR post high tech era and sort of return to a past where you just sat with your doctor and had a conversation with them. And obviously, there was always going to be some sort of like note taking and record keeping to some degree. I remember from when I was a child, like watching them go get my paper file from like the huge shelves in the back of the doctor's office, and that paper file was like what was on the table when I was like talking to my doctor. But I could actually talk to my doctor. I could look at him in the eyes, and have that sort of more relational experience like of medicine, as opposed to triangular, like you to them to the computer, type of experience. So I think a lot of people want, understandably, a lot of people want to go back to that. I think my thought is always, how then will the health systems and practices who kind of use the EHR not just as a record keeping tool, but as sort of a workflow standardization engine, quality measure reporting engine, like if you fully get people out of that software, how will they corral and influence care pathways and workflows? And will they just give up that level of influence and let us go back, and I kind of feel like the answer to that is probably not, but we'll see.
yeah. You know, what are there's obviously so much like attention in the space, like and health, AI applications in healthcare. Some of the companies like Abridge have raised tremendous amounts of money. I think their last round was like 250 million, Series D that was announced pretty recently. That's substantial. I mean, that's substantial for a non-healthcare company, health tech company. Um, we've seen companies like Hippocratic raise large rounds at over $1 billion valuation. And then I actually just saw this week, um, uh, Open Evidence raised 75 million, led by Sequoia, at I think over $1 billion valuation. And it just made me realize, gee, I'm not like keeping up with the space as well as I should be, because I was just like, who is Open Evidence? Um, and then I went onto their website and I saw that they signed a big content deal this week with New England Journal of Medicine.
Mm.
I assume to be able to train, to have access to all of the journal's kind of articles so that they could train on it. So that makes sense.
Train or just like rag over it,
I don't know. I don't know. You can only, like, if you're doing reg, or you describe reg for like a lay person, if I'm not putting you on the spot too.
I can give you my understanding of it, and
Yeah, let's go with
I
that.
mean,
We'll go with a understanding.
sure. So my understanding of it and my experience of it is, or at least my experience of what I am calling rag, is you have a workflow that includes LLMs, and then you actually sort of give the LLM the tools necessary to perform some kind of search over a corpus, whether that's a bunch of documents that you have embedded and then stored the embeddings, or you know, some other kind of retrieval method. And so you basically have a multi-step workflow where, let's say, okay, I'm asking the LLM a question, and then it is going to perform that search and then either surface the most relevant documents or surface the most relevant documents and then summarize them and then surface the summary like back to me. That is my understanding of retrieval augmented generation. Is you have instead of just having it rely only on its training corpus, you actually have steps intermediate that allow it to get more content.
It's like, hey, there's additional relevant context. Hey, LLM, there's additional relevant context out there. We want you to have access to that so you can make decisions with this additional relevant context.
Yeah.
So we're gonna like basically it's like engineering so that the LLM can go in and kind of get that information when it needs it. But to do that, so let's say that is the definition, and then we'll have somebody on and
somebody will be like, "No, you're completely wrong. I hate you."
That would be great.
These guys don't know what they're talking about.
Someday I will learn what RAG actually is. But again, assume that is the definition. Then what you're doing there, the LLM is not. So all this addition, like, so say there's like, petabytes of additional context, lots of additional context, right? I don't know what would like how if you took every article from every issue of New England Journal of Medicine ever, like how much that information that is, but it's probably a decent amount of information. You can't. The point is, you can't load all that information into the context window.
Yeah.
Even large context windows like today, and so you use RAG to say, hey, here's how you can go get new information as you see fit. But I think so. One of the interesting kind of ways, is RAG like a good way to do that I've heard from our mutual friend. I won't out him on the pod right here. I won't say who it is in case he doesn't want his name spoken. But he basically made the point like, that seems stupid because you're splitting all this. In order to do this, you have to split all this context up.
Mm-hmm.
And then the LLM has to figure out like where, it can't load everything together. So it has to be smart about how it goes and gets it. And it's just going to miss stuff. Like there's information, you're going to have to split these documents in such a way that it's not going to get everything that it needs. And so it's always going to have kind of imperfect, impartial information. And so like, I guess the point they're making is like, eventually RAG will just go away as like an engineering technique to do this, and like something else will emerge because it's like kind of an anti-pattern. So I guess back to open evidence, are they, we don't know what they're doing. We barely understand I didn't know they existed as a company before a week ago, embarrassingly. Sounds like they're crushing it, doing great.
Somebody come on, tell us what you guys actually do, please.
Somebody come on and please tell us exactly what you do. So I think the kind of back to what are the cool companies, and I think we've definitely seen some of these big companies launch, and I think we're going to find out in the next like kind of 2 years which of these are actually like real product market fit, commercial traction. I think some clearly have it. I think some it might be a question mark, or maybe the information is just more more private and it's not available in public yet. Quite the traction that these companies are experiencing. But it's going to be fun to see either way.
Yeah, it's like aligning the things that I feel like with healthcare, we just have this challenge generally, right? Where there's the interest that the patient has, the interest that various types of clinician has, and then the interests of the administrative health system, and figuring out how to align all of those interests where, usually it's the health system that's the buyer. And so you need to figure out what the like overlap is between what will people actually like to use? What are the experiences that people want that then fit into whoever the buyer is and what they are looking for, right?
Yeah.
And I think, I guess, in the sense of like, there are these informational tools, like open evidence and, like, I would say actually Atropos, where it is, I think, easier to align. Like, people want to make higher quality decisions. People want to ground their decisions in evidence. That I think that the challenge is just figuring out how do you create the experience that people want to have when they're using that tool, and what types of experiences will actually fit into the clinical workflow, right? Like adding another search portal, and having people be expected to use it while they're trying to do other things. I would argue, that could work. There was things like Hippocrates, right, that became very popular, but figuring out exactly how to do that, I think, is the challenge.
What's Hippocrates?
It was, I mean, I think it's actually still around in use. We should talk to somebody who knows more, but it's a sort of a pocket reference app, to get clinical decision support guidance. And I think it was,
Interesting. Oh, and it's like doctors use
yeah,
it, and when they're trying to be like, yeah, okay.
yeah.
Um,
I think there
I
was a
remember
time when
like,
it was super, super, super. I mean, it might still be super popular. I just know about them because they were eventually acquired by Athena, and they sat in an adjacent pod when I was at Athena, and so I would like walk by their desks all the time.
and so then that information is like doctors can query that in Athena essentially
I
when they're
I don't. I think they still kept it as like a separate app, basically.
separate product.
But
Interesting.
because I think it was it was it was part of the like web. What was that, Web 2.0, where like it was like the advent of apps. It's like,
Uh
I have the app on my phone. I don't have to.
yeah, yeah.
I don't have to add a
Yeah,
Neosphere module.
yeah, it sounds like that is kind of what open evidence is going after. I think another area that's maybe less like exciting from like doing fun stuff with the data or disrupting like or kind of like the ambient listening stuff, but it's just kind of like the process automation stuff. And I
Yeah.
think I think that, so if I could play devil's at, kind of, you made the comment earlier, you're kind of like, well, we've been like, it's been 2 years, like the stuff that's working should be starting to work, or it's probably not going to, it's going to be longer.
Well, or we just need. I mean, reasoning models are like, there needs to be much bigger context windows, or some sort of better like reasoning model, or like more determinism, or more um grounding in facts, as opposed to just, because I think like a thing that I see a lot is like, when you do max out the context window and put a bunch of stuff in, it can get kind of mushy. Like, it's sort of like when you know somebody tells you a story, and then you tell that story to somebody else about a dream that
Telephone.
they had when they were 10, and it's like, was that actually congruent with the original? Like, you're kind of, you end up sort of playing telephone with the concepts and rules and stuff eventually. I've actually seen that
Yeah.
happen even on pretty small, like if you try to, on some models, if you, before the reasoning era particularly, if you gave it a bunch of rules, you know with logical things, this and that, this or that, and like sometimes they would just get them mixed up in the middle, and so if you could, maybe that's fixed now, and maybe in the future there would be even better ways to enforce like strict logical flows of some kind. Or maybe I was just bad at prompting, that could also be the case. Like,
Yeah, you're just the
yeah.
world's worst prompt engineer. Yeah, I mean, there's a couple of ways to think about it. It's just like, what has to happen for like, AI to be actually delivering more value. I mean, one, the models can get better, the model architectures can get better, or they can just like be smarter models. Another is kind of the engineering around it, and that's kind of where I was going with the process automation type stuff. Like, I think there's this kind of like big, like 30,000 foot view of it, where it's like, oh, healthcare administration, that's like a bunch of like busy work and just shuffling of the paper. And but if we can like figure out how to inject AI in there, it's kind of like AI as RPA, 2.0, sort of. Um, and I think it's still, so I think some of that engineering is happening where it's like you build an agent to do things, but then you have to actually inject it into workflows. And I think it's still an open question as to how, like, that's probably a workflow by workflow kind of specific thing. And like, so how, can you really like, how successful can that be? Um, and then I like, maybe the third category is just like, how are we measuring like objective truth?
Yeah.
I think as the models get smarter and smarter, like two things kind of I think are probably fairly like straightforward down the middle of the fairway, like going to happen. Like the models are going to get better. Now we don't really know the pace, because it's like we're kind of at this point where we're like, ooh, have performance gains like kind of asymptoted a little bit with like more recent models that have come out. I think we're going to see that. There haven't been a lot of like bigger data centers to come online, except for the Grok data center out of Memphis recently. And so, we're gonna see how much model performance like continues to asymptote as we see these bigger and bigger data centers come online, which just takes time to build. But even if it slows down a bit, seems like they're gonna figure out how to like keep like improving at a decent, like, maybe it's not the the GPT
Yeah.
2 to 3 to 3.5 kind of like
Yeah.
100x improvement, but there's probably some degree of improvement. I would bet quite a bit on that. And then the other thing I would bet on is just like the engineering around it. Like, we figure out how to engineer the agents to be plugged into these workflows more. And so if you believe those two things, then I think it takes you to the third thing, which is just like kind of like truth, and how do we measure like objective truth, and like did it make the decision we wanted it to make, kind
Yeah.
of. And I have a lot less clarity on how to think about that. And I would imagine also for the people implementing these things in the wild at these companies, they're primarily focused on the first two things. Like, as the performance gets better, the truth kind of takes, it's not that they're not looking at it, right? But
Well,
the
I think it is
first two are
much,
probably
yeah.
taking a.
It's much harder to measure. Like, so, something that I ran into when we were making the generative terminology mapping POC was, this again was a while ago. And so the way that I was doing, and I spun it up really quickly. And so the way that I was doing it was like, I had 200,000 of these strings, which admittedly is not, that's not big data by any means, but it's still kind of a lot to be piping each one through like an API call. And then, having, especially at this time, OpenAI was new or much newer than it is now. And so like their API was down more. Like there were like a lot of these like SSL errors that would like kill like one out of every like 25 or whatever of these terms that I was bouncing. And I also didn't, the rate limit was much lower back then. And so I had to like put a whole bunch of logic in to like slow it down, have the error like have retries, but then don't keep retrying. If you retry this many times, exponential back off retries. And then how do I like keep, if I have a table with 200,000 rows in it, eventually I want the response for each one. Like, how do I sort of resiliently go in and like collect results so that if I have that one SSL error that can't be resolved out of every 1,000, let's say, if one out of every 25 fails the first time, one out of every 1,000 would like just completely fail because the API was down or something. So I just had to sort of like, I was just doing all this really janky stuff with like pandas and then saving like intermediates and then updates and so yeah, like if like that's much easier to, that's not a new problem. It's pretty easy to measure. How often is it failing? What do I need to do? What do I like? How do I could create my retry library and handle this, right? Um, it's much harder to go out and like hire a clinical expert and have them assess thousands of outputs and tell you if it was correct or not. It takes a long time, it's
and then
expensive,
and
like,
and then build a robust kind of
yeah,
process that allows you kind of selectively continue to monitor the quality over
yeah,
time. Like that's actually like somebody has to like sit down and think through that problem and
yeah.
design that. Yeah, so it's like
Well, and a
that's
lot of people have
just
made these like, oh, we're gonna sell the shovels, right? Like we're gonna make your LLM platform that can do all the monitoring and stuff, but then you have to buy into that platform and you have to learn how to use it and you have to make a commitment to it. And you're not going to be making that commitment unless you're confident that your use case is actually possible. So like you have to do it first before you get to that, and prove it out before you can actually go all in. And also all of these things are brand new. So you're talking about like, oh, I, sign a 1-year deal with my LLM monitoring and observability platform. It's like, well, you didn't exist 3 months ago. So I'm like, what,
yeah.
yeah, it's super interesting. So yeah, I think somebody needs to do the clinical. Actually, I know a company, maybe it would be fun to talk to people from the Centaur Labs who have been doing this sort of like clinical validation at scale for a long time. And I wonder if they've gotten a big uptick in people trying to prove out their LLM solution, to validate.
It's interesting. I know Eric over there, the CEO.
Yeah.
I'm sure he'd be happy to come on and answer our stupid questions. Yeah, I think they just raised Series B. So yeah, but I don't know exactly how they've been doing. Well, cool. So I guess any kind of like final thoughts here as we're like wrapping our like episode 1 like AI kind of rant or whatever we're calling this. I don't know what we're calling this.
The Phantom Menace, remember?
Yeah, the Phantom Menace. Yeah.
um, Classic of American cinema. Yeah, I think I would love to know if other, people call to action for anyone watching this who's actually implemented
The two
LLM
people.
stuff. Yeah, the 0.5 people who will watch this. If other people have experienced that sort of like mushiness of for lack of a better term, of the long context window where concepts kind of get jumbled together or rules get weirdly reversed sometimes. That would be interesting to me to see, is that a problem that people have noticed? Is it a problem that people have noticed getting better or worse? I actually thought it got significantly worse with 4 to 4.0. I think that likely it has gotten better with the reasoning models potentially because they can kind of like catch themselves more, is my like intuition, but I haven't been able to like measure that. So yeah, I'd love to know that. I'd love to talk to people who potentially have also tried to implement these things that have encountered that, because I think that's been one of the biggest challenges, honestly, is all of the stuff about retries, that's fixable and solvable on some level, but if the actual internals are getting things confused, then that's something that kind of has to get fixed on the model side.
Yeah, super interesting. Yeah, I mean, so I think our intention is to kind of have a mix of people on, trying to have some of these people on that are, starting these companies that are really making an impact in the space. We can better understand what they're doing and what they're seeing from an impact standpoint, but also have some of these people on that are like actually implementing this stuff.
Yes.
And we can get into the weeds around the engineering and like, what are they seeing? What are they running into? How is it actually working at the ground level? Are we about to like get to a takeoff point where this really like starts to solve a lot of problems, or is it going to be a little while? So
I was recently in Sacramento, which was made very famous by the gold rush, and I was thinking about how like you, in order to get rich selling the shovels, you need some people to be striking gold first. Like
someone has to find some gold.
Yeah. Like you need a couple big nuggets of gold before you can really set up your pickaxe emporium and make bank. So
100%. All right, well, this has been great, Phil. Good to get episode 1 in the books here.
Awesome.
All right, talk to you soon, buddy.
Take care.
See ya. Thanks for joining this week's episode. Next week, you'll hear our conversation with Veer Makaj, former Chief Scientific Officer at Datavant, on the state of real-world evidence. If you like this episode, we'd love for you to leave us a review on Apple Podcasts or whatever podcast player you use.